Hello students, myself Avdesh Kumar. This is my second lecture in the continuation of refraction of light. Here first topic is what are the conditions that a light ray, a refracted ray will not deviate from its original path. So there are basically two conditions. One, that is when a light ray will incident just perpendicular to the interface. It means here angle of incidence is equal to 0. Angle of incidence is equal to 0, and here it will pass undeviated, means angle of refraction will also 0. So this is your first condition, that when angle of incidence and angle of refraction both are 0, then the light ray will pass, means the refracted ray will be undeviated. Second condition, when suppose this is your normal, I have drawn a normal here, if a light ray is incidenting, at this point of incidence, then it will move along the same direction, means undeviated, means this angle I will be equal to this angle R. Okay, when this first medium 1 and this medium 2, both refractive index will be equal. It means if mu1 will be equal to mu2. It means if both medium have same refractive indices, then a light ray incidenting will pass into another medium, but it will not deviate from its original path. So these are the conditions that a refracted ray will be undeviated.
Great.
Now, factors affecting refractive index of a medium. So see, means what factors affect to the refractive index of a medium. First, temperature. See, when temperature increases of a medium, means the speed of light into that medium increases. But you know, by this formula, mu is equal to C by V. If this V will increase, mu should decrease. Thus, and V is increasing by increasing temperature of the medium. Therefore, when temperature increases, upside arrow means increases. When temperature increases, mu also implies that mu also V increases, so mu decreases. Hence, when temperature increases, mu decreases. This is the trend. Now, second, nature of the medium. This is the very most important factor. Nature of the medium means when a medium is optically denser, it means its refractive index is more. When a medium is optically rarer, it means its refractive index is less. Another means your nature of the medium. Third one, color or wavelength of light. Again, from this formula we can see V is equal to C by V, and from here C upon V. C is the speed of light in vacuum, or by the wavelength you can see. Since C remains constant, C by V, from here F lambda upon F lambda dash or lambda in medium. Lambda M means lambda in medium, or sometimes I have written lambda dash. F cancel out. Means mu is equal to lambda upon lambda dash. Lambda is, since C is constant, F is constant, so in vacuum all colors have same wavelength in vacuum. But by this formula, this wavelength and this mu are reciprocal, means inversely proportional to each other. So the color which have maximum wavelength, for that color the medium will behave as less refractive index. If lambda is more, refractive index of medium will be less. If lambda is less, this mu will be more. From behavior we know that red color have maximum wavelength, therefore for red color the refractive index of medium will be least, while violet color have least wavelength, therefore for violet color refractive index will be more, maximum. That it implies that mu for violet color is greater than mu for red color. Okay. Now refraction of light through a rectangular glass block. Refraction of light through rectangular glass block. See, suppose there is a rectangular glass block. This is a glass. Here air, here also air. As you know, refractive index of air is 1. Refractive index of air is 1. Here refractive index of glass, let it is mu. Mu G is equal to, let it is mu. Refractive index. Since mu of glass is greater than mu of air, it implies that this is your denser medium and this is your rarer, and this is also rarer. Okay. So now see, if a light ray is incidenting like this at this first interface, let A, B, C, D is a rectangular glass plate or block, and its thickness, let thickness of this one is T. So how the refraction is taking place here? At this point of incidence, let this be a normal. This is a normal. Since at this point of incidence, let O be the point of incidence. It is a denser medium, that's why the light ray, its original path is this one. So the light ray will bend towards normal. It is bending like this. Here this is angle of incidence and this is angle of refraction, let it be R. At this point, let O dash, again drawing a normal, it will come out. Its initial direction is this, but it will move away from normal. It will move. This is your initial direction and this is your final direction. Here it has been observed that these both lines, this is your initial line of incidence and initial path, and this is your final path. From here it is quite obvious that both are parallel, means when the light ray is passing through so many different mediums or through a medium and coming out into the same medium, then it will shift laterally, means initial direction is this one, but it has been shifted by this distance, so this shift is called as lateral shift. let this point be M. It means this OM is your lateral shift. Now this lateral shift depends on so many different factors. Let's see, we can calculate numerically, otherwise we can discuss with theory only. Like this lateral shift depends on angle of incidence. How? If this angle of incidence will be more, means this lateral shift will be more. Now, and also this lateral shift depends on thickness of this glass plate or glass block. If more thickness means more lateral shift. Okay. So see, I can derive this one. See how. And one more, nature of this glass block. Nature means refractive index. More refractive index, more lateral shift. I can show you, even though it is not in your syllabus, but derivation I can show you that what is the value of this O dash M, lateral shift. See from here, it is 90 degree. From this is also 90 degree. I can calculate this, let it point be N. So in this right angle triangle O N O dash, in right angle triangle O N O dash, quickly, this OM is your T. So what is the relation between this and this angle? For this angle, this is your base. So base upon hypotenuse means OO dash is equal to cos R. It implies that OO dash is equal to what? T upon cos of R. Equation number 1. Now in right angle triangle, see OMO dash, OMO dash, in this right angle triangle, we have to calculate this one. Now see, this total angle will be what? Since this is your clear initial line and this is, so these two both are vertically opposite angles, so this is your I. Now what is this much? This is your what? I minus R. Now I minus R. So from there, for this angle we have to find this when this is perpendicular. So sine angle I minus R should be equal to, sine theta is equal to perpendicular means O dash M upon perpendicular upon hypotenuse OO dash. Quite clearly, putting the value of OO dash from equation 1, it implies that O dash M is equal to OO dash into sine I minus R. It implies that from here O dash M is equal to OO dash. OO dash is what? T upon cos of R into sine I minus R. Clear? So see, if this T will increase, this O dash M will increase, directly proportional, and if this I will increase, angle of incidence will increase. Since angle increases, so sine of that angle will also increase. In this way, if angle this I will increase, then T will increase. Otherwise, from here if you will explain it, sine I upon sine R means refractive index will also increase, then O dash M increase. In this way, we can say that this lateral shift depends on thickness of glass plate or glass block, angle of incidence and refractive index of glass block.